Remember, it's face value times coupon rate. Huh? Frequency. So that's $40, all right? You get $80 per year as coupon, but every coupon is $40. If this was quarterly, they would have been $20. Obviously, C2, which is equal to C3, that's going to be $40 as well. And C4 is going to be $40 plus the face value. So $1,040. All right. T1 equals 0.5. Remember, we're measuring those in years. T2 equals 1.0. What Macaulay duration does, it basically says, calculate the average duration of these cash flows, but they're not equally weighted. They're weighted by the present value of that cash flow. So even though you're getting $40 each in the first two, the weight of those are not the same because present value of the second one is actually lower, right? So it's basically a weighted average. Oops. Of cash flows where weights are present value of those cash flows. We can calculate that relatively easily. I mean, we're going to end up writing our own function, but as of today, I'm just going to show you how to do it on a sheet. Let's leave those in there. Let me get rid of these. Come on. You're going to appreciate power of writing your own functions because Excel does not have a weighted average function. Okay. But for now, let's do this. Let's kind of do a table here. Of course, I want that sort of a standard format. I'm going to extend this up to a large number of times. I'm going to do up to 1200. All right. Delete. Cash. If the period is greater than number of coupons, obviously I get nothing, all right? Otherwise, I'm gonna get the coupon amount plus if period is exactly equal to number of coupons, I'm going to get face value Otherwise, 0. I don't know why that's 0. It shouldn't be, but oh, because it's 0 coupon. Let's make this 8%. All right. And let's make this for 2 years. Why didn't we get that? Let's see. Oh, this is why it's important to be careful about absolute references, because I'm going to copy and paste that formula all the way down. Let me make this a bit bigger. Okay. Anything that refers to cells that should remain the same when I copy and paste, I put a dollar in front of row and column references, also known as absolute references. But anything that refers to period, it's going to remain the same. Come on. No keyboard, stop. This way, if I change the coupon frequency, and after 24, it's all zeros. And let's calculate PV. I'll take that cash flow divided by 1 plus do I have a period rate? No, but I can take the yield to maturity, F4 divided by coupon frequency raised to the power period. Let me make this back into semi-annual. Okay. And all I have to do is calculate Macaulay. For each of these, I need to multiply the period with its present value, add the products up, and divide the whole thing by sum of the present values. Thankfully, we have a nice little function called sum product. And the first argument is the periods. Second argument is PVs. Come on. My computer's fighting me. Let me double click on it. In fact, sum product function is not limited to just 2 columns. If you have 3 columns, it basically, for each row, it multiplies the numbers in all of the columns and adds the products. And I need to divide that by sum of all the PVs. And for that, we have the function sum. This obviously doesn't have an interpretation of dollar. I'm going to make that general, give 2 digits. But unit of that Macaulay is number of periods, but I want to convert it into number of years. So I'm going to divide the whole thing by coupon frequency. And let's give it a nice little background format. Actually, I want to do. This basically says, on average, I'm getting my money back in 1.89 years. Okay. I mean, I get some of it in 6 months or half a year, some of it in 1 year, some of it in 1 year, 1.5 years, a big chunk of it in 2 years. But on average, I'm getting it in 1.89 years. And financial duration is easy to calculate after that.